Alright, 3.2 definition part 8.
Chebychev's theorem.
I'm not going to read out the theorem, you can read it in the book, but in essence what it says is the percent or the proportion of your population can be found within k of a jump is equal to 1 minus 1 over k squared. K needs to be bigger than 1, but your k can also be a fraction. Right, so it could be 1.5 jumps, 1 3/4 jump, etc. Now, k is the jump, just like we had for the empirical rule, and it's going to be in terms of the standard deviation. So when k is 1, you're within 1 standard deviation. When k is 1.5, you're within 1.5 standard deviations. Now, you might want to wonder, why do we have Chebychevs when we have the empirical? Well, for the Chebychev theorem, it doesn't matter what shape distribution you have. It could be bimodal, it could be skewed right, skewed left, it could be something horrendous like this image. Now, what it's telling you is plug in your number of jumps away from the mean to get the percentage. So on our first one, it's the mean plus or minus 2. So if you want to get that percent, the percent is equal to 1 minus 1 over k squared, so that's 2 squared, right? So that's equal to 1 minus 1 over 4, which is equal to 3/4, which is equal to 75%. In this formula, that's all you're going to be using. Either they're going to tell you what k is, and I'm underlining what k is here, and then you plug it in to get the area. That's it. Now, looking at the image when we started with it, see within those first jumps, that's 75%. If you'd gone out 3 jumps, you'd have been at 88.88%. So that's all we do with Chebychevs. Now, I'll give an example in a second in another video, but Chebychevs works for any shape distribution.